What's up everyone, welcome to my channel. This video is about aerodynamics. In this video, you will learn why aerodynamics is important for a race car. So without spending much time, let's start now. Before understanding the importance of aerodynamics, let's first understand what is aerodynamics. Aerodynamics is the study of how air or any other gaseous fluid interacts with a solid object which is placed in the field of flow. In simple words, we can say aerodynamics is the study of how air moves around an object. Aerodynamics is the subject that tells us how the airplane is able to fly, how the rocket launches, how a race car produces a downforce, or how the kite flies. Here, I will be discussing about the aerodynamics of the race car. So here the question comes, why aerodynamics is important for the race car? A race car experiences three forces due to air. In the longitudinal direction, it experiences a drag. In the lateral direction, it experiences a side force. In the vertical direction, it experiences a lift or the down force. Here, drag is the force which is acting in the opposite direction of motion and it tries to slow down the vehicle. It is something that needs to be reduced when we are dealing with the high-speed race cars. So, is drag an unwanted force? The answer is no. Drag can be helpful during the braking condition. That is, during the high-speed braking, aerodynamic drag can be used to reduce the stopping distance by creating the high deceleration. Another force here is the side force, which comes into action due to side winds. This force generally produces a low aerodynamic drag because of the low speed of side winds, but it can be an important parameter to consider at high speed of the side winds. The third force here is the lift. This force acts in upward direction and generally not experienced at low speed. When you drive your vehicle at high speed, you will notice that more attention is required to drive your vehicle in a straight line because lift causes instability while driving. Here, if the lift is acting in opposite direction, that is downwards, then it is called downforce, and this is the force which is important while driving at high speeds. Now, why downforce is important? For understanding the significance of the aerodynamic downforce on race car performance, we need to understand the tire load characteristics first. When you drive your vehicle, driving force, braking force, and cornering force all are generated at the contact patch between tire and road. These forces are affected by the vertical force applied on the tire, and their maximum value is limited by the friction coefficient. So here we know that the friction coefficient is constant, and to increase the value of these forces, we need to increase the vertical force. For example, suppose we are taking a turn at a particular speed. If we increase the speed of cornering just above the maximum value, the car will slide off the track. This is the result of exceeding the limit of tire adhesion. Now, if we could increase the normal load on tire by pushing the tire more against the road, then the cornering force can be increased. One way to increase the normal load on tire by putting the extra weight on the car. But this will also affect the acceleration of the vehicle and also the force needed to turn the car. Another way is the aerodynamic downforce, because this will add the additional weight on tire without increasing the vehicle weight. And as the load on the tire due to downforce increases, its cornering ability at high speed also increases. You will understand this more clearly using the tire load curves. Here we are having the curve between the lateral force and the slip angle on the vertical load of 200 kg. Now suppose your car is taking a right turn, and due to which it will experience a centrifugal force. And due to this centrifugal force, the tire will experience a lateral force which is given by Fy equals to C alpha multiplied by alpha. Due to this centrifugal force, the tire will have some slip angle, and this will be the direction of travel. If you don't know much about slip angle, lateral force generation, direction of travel, you can check my video on slip angle and lateral force from the I button above or from the link in the description box. Okay, so now this lateral force Fy equals to C alpha multiplied by alpha is valid up to a point where the lateral force is directly proportional to slip angle. Suppose that point is 4 degree slip angle. Now at this point you can see we are achieving the maximum value of the lateral force. Also, note here the maximum value of lateral force at particular vertical load is given by Fy equals to mu y multiplied by Fz. So at 4 degree we are achieving the maximum value of lateral force, and this maximum value is currently balancing the centrifugal force. Now here in this particular situation, if we increase the value of centrifugal force by increasing the cornering speed, we will come in a situation of increasing the slip angle. Now if the slip angle is increased beyond 4 degree, you can see the value of lateral force will not increase and will be at its maximum value. So at this situation you can see the value of centrifugal force will be greater than the value of lateral force, which will make the car to slide off the track. So what we can do here to prevent this sliding and increase the cornering speed? We can do two things. Number one, if we can achieve the same maximum lateral force at the lower slip angle, that is point B, suppose 2 degree. Or number two, if we can increase the vertical load at the same slip angle of 4 degree, that is point C, which will give the increased value of the lateral force. So here by joining the point B and C, we can get the tire load curve at the increased value of vertical load, suppose 300 kg. So by increasing the load, you can see we can achieve the greater value of lateral force at the same slip angle of 4 degree, or we can achieve the same value of lateral force at the lower slip angle of 2 degree. In both of these cases, we will get the extra value of lateral force to tackle the centrifugal force at high speed. Hence, the increase in vertical load can help us to corner at high speed, and we can reduce the lap time. So this is the importance of aerodynamic downforce, which increases the load on the tire without increasing the weight of the car. Here it was the case of cornering, where we considered the side slip and the lateral force. You can draw a similar curve between the longitudinal slip and the longitudinal force to analyze this situation, and you will notice the similar increase in the value of traction while accelerating on the track with the downforce. Also, note that downforce and drag both occurs due to longitudinal movement of air. That is, while achieving or increasing the downforce, you have to face drag also. So the race car design should focus on balancing the downforce and drag in such a way we get the maximum value of downforce and minimum drag. So I hope you understood the importance of aerodynamics in race car. This much for this video. If you have any queries, you can comment in the comment box. If you find the video useful, do like it, share it. Also, subscribe to my channel, hit the bell icon to get the latest updates. If you want to check my blogs on vehicle dynamics, automobiles and software, you can check on my website. The link is in the description box. Till then, keep learning, keep exploring.